Welcome to qnawire.
In this question, we have two thin rods of length L. They are placed at the position shown, and then each of them carry a charge Q uniformly distributed along the rod. We want to find, there are three parts in this question. We need to find the electric field due to the left rod along the positive x-axis, then find the electric force due to that the rods exert on each other, and show that the formula for the electric force reduced to the point charge formula when the distance between the rods are much larger than the length of the rod. Okay, so in this question, we are working with continuous charge distribution. So we are going to cut the left rod into very small pieces. Okay, and at the same time, we also need to define the linear charge density, okay, of the rod. Okay, so this is lambda, which is Q over L. And then this is our dq that we are going to consider. Okay, and then for this dq, it generates an electric field at this point x. Okay, that's pointing to the right. Okay, so using dE equals to 1 over 4 pi epsilon naught dq over r squared. Okay, so our r is measured from dq to the point x. Okay, so I'm going to call this x prime. Okay, so our dq is lambda dx. This is q over l dx. Okay, and then our r is x plus x prime. Okay, so the x is fixed. Okay, and then x prime is our integration variable. Okay, so I'm going to put the dq as lambda dx prime and dx prime. Okay, so we can set up our integral right now. Okay, so our x prime, okay, goes from minus a over 2 minus l to minus a over 2. Okay, this is our limits of integration. Right, so now we can find the electric field due to the left rod along the positive x-axis. Okay, so we'll integrate dE. Okay, we integrate 1 over 4 pi epsilon naught q over l dx prime divided by x plus x prime square. Okay, and then the integration starts from minus a over 2 minus l to minus a over 2. Okay, so I'm going to pull out the constants q over 4 pi epsilon naught l. Okay, minus a over 2 to minus a, from minus a over 2 minus l to minus a over 2 to, and then this is 1 over x plus x prime square dx prime. Okay, so we can integrate this directly. Okay, so this is just because we are integrating with respect to x prime, and then the numerator is just x prime. So the denominator only has x prime. So if you differentiate that, you get 1. So this means that you can actually obtain this expression, okay, immediately. Oh, Yes. Okay, one thing I forgot to mention that in this diagram, the x prime is negative. Okay, so to be exact, forgot. Okay, this should be x minus x prime. Okay, yeah, because x prime is a negative number. Okay, it's a negative number, and so there is no negative sign over here. Okay, you obtain this. Okay, I hope this is clear. Okay, x prime itself is negative. Okay, so the r will be x minus x prime as mentioned in this box. Okay, so then r will be a, a big number. It's not plus. Okay, yeah. Okay, so when you do the substitution of the limits, okay, then you get 1 over x plus a over 2 minus 1 over x plus a over 2 plus l. Okay, so you can choose to simplify or you can just leave it like that. Okay, and both are fine. Okay, so this is the answer for part A. Okay, then in part B, we want to find the force that the rod exerts on each other. So using okay, so what happens is that in our situation, okay, we found a field at this point, suppose. Okay, and at each x they have different E, right? But and then we just consider the dq over here, okay, and then we multiply by the E, we obtain the df. Okay, so the df is equals to E dq, okay, and then the dq is still lambda dx, okay, q over L dx, and then the integration limits this time is we integrate the positive side, it makes it easier. Okay, right, so f is integral of df is equal to e dq. Okay, the limits of integration is a over 2 to a over 2 plus l. The e is the expression that we obtained above, so we pull the constants out. 4 pi epsilon l integrate q over l dx divided by, oh, not divided by, just to write nicer. Okay, so the dq has q over l, right? And then the e inside the square bracket is 1 over x plus a over 2 minus 1 over x plus a over 2 plus l dx from a over 2 to a over 2 plus l. Okay. Okay, so we pull out another constant. Okay, and then for each term you get natural log. After the integration, okay, and then then you start to put inside the thing, so you get a plus l minus 2a plus l minus natural log a plus natural log a plus l. Okay, so if you group everything together, here you get natural log a plus l square divided by a plus 2l. Okay, this is the expression that you are supposed to get. Alright, so this is our electric force that the rods exert on each other. Okay, next in part C, we want to calculate what happens when A is much greater than L. okay, and show that the expression in B reduced to a point charge formula. Okay, so this is what we do for A much greater than L. Okay, this means that L over A is much less than 1. Okay, and we are also given the expansion for natural log for small z. Okay, so this we can do something to the natural log expression that is given to us. We want to utilize the L over A much less than 1, so we can actually pull out the A from the numerator and the denominator. Okay, so you get natural log of 1 plus L over A square minus natural log of 1 plus 2L over A. Okay, I'm going to simplify further. Put 2 natural log 1 plus L over A minus natural log 1 plus 2L over A. Okay, so with L over A much less than 1, okay, natural log of 1 plus L over A is AL over A. There's no need to put the approximate sign, you can just put equal, and this is what we get, minus L square over A square times half. Okay, then plus natural log of 1 plus 2L over A is equal to 2L over A minus half times 2L over A square plus this is equal to 2L over A minus 2L square over A square plus So you can substitute these terms into the above expression. Okay, so 2 natural log 1 plus L over A minus natural log of 1 plus 2L over A, okay, is approximately equal. So I'm just going to do until the L over A square term. Okay, 2 times L over A minus half L square over A square minus 2L over A plus minus 2L square over A square. Okay, then simplify, you see that this term cancels out, and then what you are left with would be L square over A square. Okay, so the F is this is what we get last time. Okay, and when A is much larger than L, okay, then we have Q square over 4 pi epsilon naught L square times L square over A square. Okay, you cancel the L square, you get Q square over 4 pi epsilon naught A square. Shown. Okay, so this is how we obtain the expression. Okay, so reason, so when A is much larger than L, okay, the two rods are very far apart. From each other. Okay, so they appear as point charges to each other. When they are far apart. Okay, so this is how you do part C, and that's all for this question.